Hi, I'm Chris Brown, and this is Lecture 7 in Intermediate Axiomatic Design, the second part in this course on axiomatic design of manufacturing processes. And I'm going to be talking about coupling and how it goes from child to parent. So this is DPFR coupling and what I call inheritance. And so can a child be coupled and the parent not? No. Not if the decomposition is collectively exhaustive, because that would mean that the child must be part of the parent. So as long as the sum of the children is exactly equal to the parent, the children are coupled, the parents must be coupled. So let's take a look at an example. Now, this is being done in a Claro, which you can get from axiomaticdesign.com. And so here we're looking at provide interstate transportation, or transport things at an interstate level. So the DP is somewhat generic, it's an interstate transportation system. And so let's decompose the kinds of things we want to transport: merchandise and people. And so then a merchandise transportation system and a transportation system for people. So we're consistent with we've decomposed in this case what we're going to transport, and the children of system are system, and the children of transportation, I guess, are transportation. Or our transport. All right, so if we take a look at the upper level design matrix, at this point, it looks like it should be diagonal. And as I've said before, expressing this as being diagonal at this point essentially is representing our optimism that we will be able to find a decomposition that will in fact keep this as diagonal. And so we need to drive this down further. All right, so let's decompose the next two levels. So transport merchandise. So now let's decompose transport at this level. So this is similar to what I talked about in an earlier one. We're going to decompose the noun and the verb. So now decomposing the transportation part. So, or the two different components, right? So, so carry merchandise and transmit merchandise. So to carry the merchandise, we need some sort of vehicle like a truck, and to transmit it on something, we need an interstate highway, for example. So if we decompose transport people, we would carry people in the cars, and we would transmit the people on the same interstate highway system. So this should right away let us know there's a problem because we've used the same DP for two FRs. But let's see what happens and how this plays out. Now, we could take something less obvious where there's a less obvious conflict, but I think what we're trying to look at here is the inheritance question. So, and the point is that if we do anything to the interstate highway system, it will influence the transmission of both people and merchandise. Now, let me make one point here as an aside, that almost anything we do to improve the transportation of merchandise will also improve the transportation of people and vice versa. So we need to think at some point, is this really a good decomposition? But let's put that point aside for the moment with that critique. And let's go ahead with the exercise so we see the inheritance. So if we expand this now and we take a look, the software, a Claro, always starts with a diagonal matrix. Now this assumes that we've selected the DPs appropriately so that they do in fact influence the FR. And now it's up to the user to fill in X's and O's in these green squares. And they've chosen to leave some gray and some green, and there's some interesting choices there. So as we start looking at each DP and going down to see which FR it might influence, and leaving this gray means that, yeah, we thought that this dp should influence this fr, and naturally we don't need to see that it influences the children. So that's why those are gray. But at this point now we could put an X or an O in. I've chosen to leave it blank. So the merchandise and transportation system, what does it do? The merchandise transportation system, what does it do to transporting people? Is there an interaction there? Well, so it may not be obvious right away. So let's see, do the trucks make any influence on this? And so the truck specifically, we would say no. But let's now say, all right, the interstate highway transmitting people, yes, that does influence that, because people are transmitted on the interstate highway as well. So we would start off putting an X in this position, and this might be the first place where we think we have an interaction. So we're working systematically through the possible influences of the dp's on the FRs, and we come up here with an X. So this is the first place we're recognizing that there's coupling in this particular exercise. So we've left the O's off because we want to see what's going to happen next. So if dp 1.2 is influencing a child of transport people, then it must also be influencing transport people. So we'll include an X there. And this is provided the decomposition is CME. And we have to enter that X manually. So that sort of coupling gets promoted up to the parent of transmit people. So then, where else can this go? Well, so we have the first inheritance. The second inheritance now, if dp 1.2 is influencing transport people, then it seems that the parent of dp 1.2, which is dp1, should be also influencing the parent here. And so now we have a second inheritance in the matrix that we have to enter. So provided the decomposition is CME, then dp1 must also influence fr2, and the coupling moves up from the details to the more abstract levels. So now we see there's coupling between dp1 and fr2, which wasn't obvious before. Now we could do the same thing over here, because the same interstate highway system influences transmit merchandise. This is the intended interaction here. This is the unintended one that we're discovering now. And so it makes the same sort of jump, and it's going to influence the parent, and then it's also going to influence the parent of 2.2 is going to influence the parent of FR1. Now, an interesting thing here happens. We see that this little part is fully coupled and cannot be decoupled, and it makes a little square there. Now, this is the first time the software has recognized there's a problem, and it would not have recognized it had we not done this little promotion exercise. But this, in fact, is the case. And so this is the first time it becomes obvious to the software, but we could have recognized this earlier as well, if we had known what we were looking for. We have an X there, 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 and there. And these little squares of X's are something to look out for, because they can't be rearranged using the linear algebra. All right. So now we show the upper level coupling, and it's all pink because obviously here we can't rearrange the matrix to sort this out, because we already have got nothing but X's at this level. So the system is fully coupled. So our earlier optimism was unfounded. And so anyway, so you can think about this coupling the next time you get stuck behind two trucks that are trying to pass each other over several miles, going under the speed limit, sometimes significantly under the speed limit. And it's this kind of frustration that you can think about too when you're looking for possibilities for innovation. So what should we do? Anyway, to go back to this point about when the coupling became obvious to a Claro. So at this point, had we just done the lower level and not done the promotion, there is a square here, and these squares are something to look out for. And so when we saw that we were putting in the second x, that should be a signal to return to the dp's and figure out what we can do. So what could we do to decouple the transportation system? Well, we could add some dp's. Sometimes you add an extra lane and you don't allow the trucks in there, so now we've got a separation. We could add more highways, and this might be advisable in some places. Or we could have separate systems, like canals or rail or air, and then we could have separate trains, separate tracks or something. But these all require investment in infrastructure. Thank you for your attention.